Hello, everyone. I wanted to make you a quick video to help with proving identities in Module 10. We did get to one of these today in class, but we didn't get to the other two. So I just wanted to kind of go through and give you some more examples of these because I think proving identities are always something that is, it's a challenging skill. Um, so I just, yeah, hopefully this is helpful. Okay. So we are proving this first identity, 2 times the cotangent of x divided by the cosecant squared of x. All of that should simplify down to the sine of 2x. So we're proving an identity here, so we're going to pick one side and one side only. I think the left side looks scarier, so I'm going to pick that one. So I'm going to rewrite it to say this is where I'm starting my directions from. And so that we get a nice clear connection between one side and the other. So here is where I'm starting, and we're just going to try to connect some things. So let's see. I have a cotangent that I could turn into either 1 over tangent, or I could turn that into a cosine of x over the sine of x. And I have a cosecant squared of x, which I can either go to Pythagorean identities, or I could write cosecant as 1 over sine of x and then square that whole thing. So honestly, it's a trial and error thing right now. I'm going to start by putting everything in terms of sine and cosine because I want to get to something with a sine in it. So I don't think I want to go to tangent because that's really not going to help me get to sine. So I'm going to put cotangent into sines and cosines. So that will be cosine. Again, these are trial and error. I'm just trying to explain why I'm picking this one to start with. Um, so yeah, I want to come to sines and cosines so that I can get to stuff with just sine in it. So I'm replacing cotangent with cosine over sine. And then for cosecant, I could use Pythagorean identities and replace that with something with a cotangent squared, but I don't think that's going to be as helpful because I want something with a sine in it. So I'm going to use that cosecant is 1 over the sine of x. And since cosecant is squared, sine will be squared as well. Okay, so I've replaced this with 2 identities. I'm going to go ahead and make note of this. Up here, this was a quotient identity. And down here, this was a reciprocal identity. And up here, I have 2 over 1, just for my brain's sake. Okay, so now I'm here. I've got 2 cosine of x over the sine of x, all over 1 over sine squared of x. Since I have fractions within fractions, I can keep change flip. Again, on top you'd multiply across, but I can basically just connect these and I would have 2 times the cosine of x all over sine of x. So I'm going to keep the top. I'm going to change this division to multiplication, and I'm going to flip the bottom. So I would have sine squared of x over 1, and that is algebra. Right, keep, change, flip. Okay. And again, you don't have to write more than algebra. Just trying to be helpful there. And then let's see, where do we go from here? I've got 2 signs on the top and 1 sign on the bottom. So this one will cancel one of these. And so what I'm going to be left with then is going to be 2 times the cosine of x times 1 sine of x all over 1. Since it's all over 1, I don't need to write that. So let's see, that was just algebra. That was canceling and multiplying. So let's see, where are we trying to go here? I'm trying to get to the sine of 2x, and I'm at 2 times the cosine of x times the sine of x, which is a double angle identity, and I am where I want to be. So I am just going to end this where I want to go, because double angle identities. And we're done. So again, just try some things, and again, evaluate different options. And if you start and it didn't go the way that you thought it would, then just come back and try something different. Okay, so how about number 3? If I wanted to verify that cosine squared of gamma was equal to 1 plus the cosine of 2 gamma all over 2, if I wanted to verify this, I have to pick a side. I think that the right side looks a little bit scarier to me, so I'm going to start there. 1 plus the cosine of 2 gamma all over 2. So that's where I'm starting. You could start at the other side as well, but cosine squared of gamma, it's harder to see exactly where to start with that one to simplify it in the right way. So I'm going to start with this one because I think this looks more complicated. Okay, so I'm starting here, and I am looking for something to do. So let's see, I've got a plus here on top, which means the um, conjugates might be an option for me. And I also have a 2 times an angle inside a trig function, which means double angle identities might be an option for us as well. So um, I can try conjugates or double angle identities. I'm just going to go ahead and look at the double angle identities and see what we've got. I've got cosine of 2 gamma, cosine of 2 gamma. Okay, so cosine of 2 times an angle. I have 3 different options to use here. So again, even if I wanted to use double angles, I would have 1, 2, 3 different ways that I could plug in for that. And it's just a trial and error thing. But let me think about where I'm trying to go. I know I want to end up at the cosine squared of gamma. So I probably want to replace cosine of 2 gamma with something with a cosine squared in it. So if I come back up and look again at my double angle identities, I've got a cosine squared in this one and a cosine squared in this one. So I think the top or the bottom would be the 2 best options for us. And since my final answer is just a cosine squared and it doesn't have any sine squareds in it, I'm going to try the bottom one first, just because this has a cosine squared and no sine squared. This looks closer to where I want to go than the top one. So I'm going to use this bottom one. I'm going to try a double angle identity and just see where that takes us. So the cosine of 2 times gamma is going to be 2 times the cosine squared of gamma minus 1. So let's come back down and try that one and see what happens. So I'm going to have 1 plus the cosine of 2 gamma is going to be, again, sorry, it's gone, 2 cosine squared of gamma. 2 cosine squared of gamma minus 1. Come on. There we go. All over 2. Okay. And that was a double angle identity. Okay. So we replaced the cosine of 2 gamma with 2 times the cosine squared of gamma minus 1 from our double angle identities. So now from here, those parentheses on top aren't really doing much because we're adding. So I'm going to go ahead and remove them because they're really not doing anything. So I've got 1 plus 2 cosine squared of gamma minus 1 all over 2. And so now I've got some like terms I can combine. 1 minus 1. That's 0. These guys cancel. And so all I have on top is 2 cosine squared of gamma over 2, but I've got a 2 on top and a 2 on the bottom, so those cancel as well, which means this is just the cosine squared of gamma, which is what I wanted. And so this is all just algebra. Doing that in a different color. Here we go. Better. And this is all just algebra. I'll just say canceling, and it's combining like terms. So canceling. Okay. Awesome. So that worked out. And again, just kind of try to use your best guess of um, what will help you get to where you need to go. It's all trial and error. And just kind of keep in mind where you're going. If the first thing that you try doesn't work or you get stuck, just go back and try something else. These are puzzles to solve, but I hope that helps kind of go through your options and just figure out how to tackle those. Have a lovely day, and I will see you on Friday.